And welcome. Today we are going to pull back the curtain on a word that sounds way more complicated than it is, polynomials. But here's the thing, they're not just some random math concept. They are one of the most powerful, most creative tools in all of algebra. And by the end of this, you're going to see exactly what I mean. Let's get right into it.
So, to get us started, let's look at something we can all picture. Just a simple square. Let's say each side has a length of x. Now, how would we write down a little formula for its perimeter, the distance all the way around, and for its area, all that space inside? Well, the perimeter is pretty easy, right? It's just x plus x plus x plus x, or a much cleaner way to say that is just 4x. And the area, that's length times width, which gives us x squared. And believe it or not, these two little expressions, 4x and x squared, are the perfect building blocks of polynomials. See, we're already doing it. Now let's give it a proper name and see how powerful this gets. So here's our game plan. We're going to start with the absolute basics. What even is a polynomial? Then we'll take one apart, piece by piece, learn how to name them, and figure out the most important way to classify them. And then we get to the really cool part, finding its zeros and seeing how that unlocks the secret to its factors. Okay, first things first, what actually makes some random expression a polynomial? It turns out it's actually super simple. It all boils down to one single rule you need to know. And here it is, the golden rule. A polynomial is just any algebraic expression where the exponents, those little numbers up top, are whole numbers. That means 0, 1, 2, 3, and so on. No fractions, no negative numbers allowed up there in the exponent. That's it. That is the whole secret.
This chart makes it crystal clear. On the left, everything looks good. The exponents are all whole numbers, so it's a polynomial. But look at the right side. That expression x plus 1 over x, well, that's really x plus x to the power of negative 1. And since negative 1 isn't a whole number, nope, not a polynomial. Same deal for the square root of x. That's just a fancy way of writing x to the power of 1/2. A fractional exponent, that disqualifies it. It really is that straightforward.
All right, so now we know how to spot a polynomial in the wild. Let's put one under the microscope and see what it's made of. Think of it like we're popping the hood on a car to see how all the parts work together.
So this is going to be our guinea pig for the next few slides. Negative x cubed plus 4x squared plus 7x minus 2. Let's break this thing down.
First up, we have terms. Those are just the individual chunks separated by the plus or minus signs. So for us, that's negative x cubed, 4x squared, 7x, and negative 2. Easy enough. Next, the coefficient is just the number out in front of the variable. So for 4x squared, the coefficient is 4. And what about that negative x cubed? Well, there's a sneaky negative 1 hiding there. And finally, the constant is the term with no variable at all. In this case, it's negative 2.
Okay, so we know the parts. Now let's see how we give these things names. There are two main ways to classify a polynomial, and the first one is about as simple as it gets. You just count how many terms it has.
This is pretty intuitive, right? If it has just one term, it's a monomial. Mono means one. Got two terms? It's a binomial. Bi for two. And if it has three terms, you guessed it, it's a trinomial. Tri for three. If it has any more than that, we usually just call it a polynomial.
Now, counting terms is fine, but this second method of classifying is way more important. This is how mathematicians usually talk about polynomials, and it's all about finding the highest power.
It's beautifully simple. The degree of a polynomial is just the highest exponent you can find on its variable. You just scan the whole thing, find the biggest power, and that number is the degree. It tells you more about the polynomial's personality than anything else.
This table lays it all out. A polynomial with a degree of 1, we call that linear, because its graph is literally a straight line. A degree of 2 gives us a quadratic. You've probably seen those U-shaped graphs before. Degree 3 is cubic. And what about just a number, like 7? Well, you can think of it as 7 times x to the power of 0. So its degree is 0, and we call it a constant. These names, especially linear and quadratic, are everywhere in algebra.
Okay, big shift here. We've defined them, we've named them, now let's actually do something with them. The single most common task you'll have with a polynomial is to find its zeros, which is really just a fancy way of saying you're trying to solve it.
So what on earth is a zero? It's like a magic key for the polynomial. It's that one special number that if you plug it in for the variable, makes the entire expression equal to 0. It's the value that makes everything perfectly balanced.
Let's make this real with a super simple example.
Is -2 a zero of the polynomial x plus 2? Well, the process is simple. Step 1, just substitute -2 in for x. That gives us -2 plus 2. Step 2, do the math. -2 plus 2 equals 0. Since we got 0 as our answer, then yes, -2 is absolutely a zero of that polynomial.
Okay, let's just clear up a few common questions really quick. First, as we just saw, a zero of a polynomial doesn't actually have to be the number 0. In our example, it was -2. Second, the number 0 itself can be a zero sometimes. Third, a simple linear polynomial will always have exactly one zero. And finally, yeah, more complicated polynomials can definitely have more than one zero.
Okay, this is it. This is where everything we've been learning comes together in this really beautiful way. We keep talking about finding these zeros, but why? Why does it matter so much? Because finding a zero is the key that unlocks something even bigger, the factors of a polynomial. This is the ultimate connection.
This right here, this is the secret sauce. It's called the factor theorem, and it is a total game changer. It says that if you find a number, let's call it a, and that number is a 0, then you automatically, instantly know that x minus a is a factor of your polynomial. It's like finding a solution gives you a piece of the original puzzle.
Let's watch this magic happen. We want to factor y squared minus 5y plus 6. A good place to start is to test the factors of the constant, which is 6. So let's test 2. We plug in 2 for y, we do the math, and we get 0. Boom! The factor theorem tells us that because 2 is a 0, y minus 2 must be a factor. Now let's try 3. We plug it in, and we get 0 again. So y minus 3 must also be a factor. And just like that, we figured it out. Y squared minus 5y plus 6 is the same thing as y minus 2 times y minus 3. So cool!
And there you have it. In just a few minutes, we have built a complete toolkit for understanding polynomials. You know what they are: expressions with whole number exponents. You know their parts: terms, coefficients, constants. You know their most important feature: the degree. And you know the ultimate secret: finding a zero